I told him, okay, what is multi-threading? What is asynchronous programming? What is parallelism? So this is where the problem lies, is where we need to connect the dots that are scattered here and there, and let's try to do that. So whenever you write a program, right, it could be just a server, like let's say I wrote a Node.js server in this machine behind me, and I'm running it as one of the processes. So you write a program, it becomes an executable after compilation and stuff, you run it, it becomes a process. So a process is a program in execution. That's what it means, and these processes kind of multiple stuff. Like, what is my Node.js process doing? It's just trying to listen to a port, okay, and will accept any request and do some job, okay. That is a job of a server. Your process can do any kind of tasks, okay. So server is just a running program or a process. Now let's think about this, that it's not just one process that is running on this machine. There are multiple applications that are running over here, and it means that there are number of processes running on this machine. How does everyone get a chance at the CPU? Because your process might be doing some CPU intensive job, who knows, right? I mean, it could be doing some CPU work, it would be doing some input output work. This is where it comes, like, we define as a process as a CPU bound, and you as a programmer has to really identify that is your program doing a lot of computational stuff, right? Or is it just doing some input output and spending very less time at the CPU? Yeah, like, you have to judge that while you write a program, like, that's how, because it's your application, it's your process. You have tens of processes. Your operating system picks one, schedules it on your CPU, and that is how your CPU gets to execute the processes. And how it schedules it one by one, algorithm, like, you have round robin algorithm, for example, so that each of the processes gets its share of CPU for some interval, for, let's say, 2 seconds, 3 seconds, 1 second, whatever. So your process goes to the CPU, executes something, does some computation with the help of CPU, and comes out of it. Then another process goes over there. So this is how the management of the processes, or we call as task scheduling, is done by the operating system over the CPU. And where is parallel programming? Your parallel programming will never happen until you have more cores in your CPU. So the actual multitasking only happens when it can be done in real parallelism, so it's like you have two cores, then your two processes can go to each of the core and can do their job. It means at a time you can have execution of two processes over the CPU. So this is called parallel computation, and this is what parallelism means. To what does concurrency mean? So we just read about concurrency. So even parallelism can be called as a type of concurrent programming, because you are trying to do, obviously you are doing multiple things at the same time. uh, what was your OS trying to do is not getting blocked upon one process, right? In those scheduling algorithms, even that is concurrency. You can even tell that, because it's a way of, there are multiple processes, okay, who are trying to circulate through the CPU, getting their chance at the CPU. So one process would not be staying blocked, okay, if it has nothing to do over the CPU. So everyone is important. Now you can also define concurrency in the scope of the same process, and we call it as, for example, you have a work to do, you want to do multiple stuff, you don't care about other people here, right? You don't care about other processes. So you have one process, how to achieve concurrency. So one way to achieve concurrency in your own process is to have multiple threads, right? So what you can do is create a different sequence of executions or you can create different threads in a process. Now what that means, so when I was talking about process all the time, I meant that there is just one single main thread, right, with each of the processes. But you can define some more threads. It means your operating system gets to schedule more of your threads. It means that you are able to enable execution more of yourself, right, by having multiple threads. Okay, and that can happen even with a one single core CPU. But that wouldn't mean a parallel program. It would just mean that you are trying to achieve concurrency, not just getting stuck doing one thing at a time. So for example, your thread 1 can get a chance at the CPU, it gets rescheduled. Your thread 2 will again get a chance at the CPU, gets rescheduled, and maybe now the other thread from other process gets a chance at the CPU. So this is how the entire ecosystem you can have a model in the mind. So now what you can think of it is, now you create multiple threads from where, right? Thread is a operating system resource. You tell the operating system to create a thread for you, and you have various languages to do that. Okay, in Java you can create a thread from your application, right? And why do we need threads, more threads? Again, like you are enabling your or increasing your chances to do more of your work. Okay, so if you have more threads, right, uh, your own process won't get blocked doing one stuff. Okay, you have another thread for doing some other stuff of your own job, right, of your own process, and that's where these threads come into the picture. And remember, it's all an operating system resource, so you'll be using those resources of your machine. So I have a Node.js process running. I can create a one thread out of it, right? And by the way, Node.js uses a system called as libuv, which is capable of creating more threads for doing some stuff. So we have multiple threads. Just now, Node.js has a multiple threads for doing its own stuff. You know, other people, other processes are running on this machine, but I have 4 threads dedicated to my work. And that's how I'm not getting blocked on one stuff that I'm doing, but I'm able to execute more. So we just talked about threads, and if you're creating more threads, it means you are uh, like increasing more chances of switching, context switching between the threads. And if your program has more threads, your stuff, for it to complete or for your stuff to be done, you will have to spend more resources. More context switching thread is a resource at the end of the day. So remember that this is how the entire ecosystem works. And let's come to asynchronous programming. Now asynchronous program is a very broad term, so it's like concurrency in a single core CPU. We just talked about it, right? Concurrency in a single core CPU can be called as asynchronous way of doing things, because you are able to not block at a one task. Now asynchronous programming in your own process, how can we achieve it? If your program is able to do non-blocking operations, it's like if it's able to make a network call and not get blocked upon that, it can do rest of the stuff, then it can be then it can be called as asynchronous program. Now, there are multiple ways of achieving asynchronous program, and some of them we have already talked about. Create number of threads, right? In a program, you will be able to do lot of stuff, right? You will not get blocked on one stuff, one thread for input output, one thread for another job, and you're not getting blocked. Uh, so asynchronous multi-threaded environment. Okay, so this is called achieving asynchronous with multi-threads, with multiple threads. Asynchronous programming can be also told as if it's a parallel programming, right? So parallelism is also a type of asynchronous program. And so now you are able to connect the dots, right? These all are interrelated, but you cannot tell everything is same. So you can say like, so now one of the cool ways what Node.js does is that it achieves asynchronicity with the help of just single thread. Now this entire term is a bit weirdly used because Node.js internally uses more threads, So a bit debatable, but we can talk about it in another video. But in short, these three concepts like asynchronous, multi-threading, and parallelism, these two are very interrelated. Asynchronous is concurrent programming. Okay, it means that you are able to schedule more things, do more jobs. Your OS is able to do more jobs, not get stuck at one place, right? Multi-thread, you're able to create more threads from a single process and able to do more tasks of yourself. Okay. Parallelism is like you are leveraging the hardware of your machine, having two cores, you are able to do more stuff at actual multitask. You are actually doing parallel things. So when I hope this video helped you, and if there's any question, just leave down in comments. We'll try to answer, and I'm pretty sure there will be some good people who will also answer your doubts. So let's see you in another video.